Hey there, how's it going? Yeah, so today I'm gonna do a live coding of an Android app using Kotlin. I'm going over some of the basic components. Maybe some of you already know how to do some of these things, but I'm gonna be sure that I'm focusing on what we think is the best structure to build an application with Kotlin. To do so, we are gonna build a logging screen. As many of you have seen in most of the application is really a common interface, right? You have to, in any application, eventually have a user that has input some email and password. And I think it's a perfect showcase that puts together some of the basic concepts of a user interface, a user inputting, um, doing some actions on the interface, and then you handling some sort of logic that requires to, in this case, validate the email, validate the password, and then do some progress showing, and then finally handle the failure or the success tree. So the main goals I'm going to focus today are going to be like how to start from scratch with Android Studio, understand some of the basic concepts, and then how we can build this simple interface that allows the user to input an email, input a password, and then show some status based on the user input. Either it's loading when the user submits the email and password, or it failed, or it actually succeeds. Finally, we are going to run the app with the Android emulator and see what are the results. In order to do so, I'm going to use Android Studio, the latest stable version. It actually came, I think, last week, that it's the version 4.0. You can get it through the link if you have not already, and it will automatically install you all the necessary tools that you need to build an Android application. I will be using some small subset of Jetpack libraries to bootstrap the application. In case you don't know, Jetpack libraries are a set of libraries made by Google that are aiming to accelerate the development of Android by providing some frameworks and some mechanisms already built on these kind of libraries that allows you to quickly do some of the common patterns and follow some of the guidelines that we have. As well, it helps on the backwards compatibility. So it handles for you different Android versions. So you don't have to worry that much if your users are on Android 6 or Android 8 or whatsoever. And obviously, we will be using Kotlin. So with further ado, I will switch to Android Studio. All right, I think we are ready here. Okay, yeah. So let's start with Android Studio. We are going to start with the new Android Studio project. We click this button, and in case you're not familiar, this is a set of templates that the Android Studio offers to you to already pre-build some of the common activities or common patterns on Android, from building a Google Maps, a logging activity. We will not be cheating here. We will build it by our own. And then the one that I'm going to pick is this one. It's called Fragment plus Viewmodel. This will automatically create the necessary components and classes and add the dependencies that we need for building a fragment with a component called Viewmodel. It's part of Jetpack Libraries. So we click Next, and yeah, so we're going to say Kotlin login, for example, and then we define the package name. This is the ID of your application. You can change it later. We obviously want to use Kotlin, and then here we can choose the minimum SDK that the application is going to run with. Android Studio offers this nice thing here that it tells you already how many devices are supported by this minimum SDK. So depending on what you select here, it means that users with, for example, like this, users with an Android 6 will not be able to use your application, but you can change this later as well. So let's start with the 21, would cover most of the devices on the wall. Simply, we click Finish, and this will automatically open the project and create all the file structures, add the dependencies, and we'll start now building some of the project till it's set up. I'm going to switch to the presentation mode so you all can see a bit better. Whoa. All right. So as you might have seen, it was doing a lot of loading and things. But now it's finished, and it has set up our main structure based on the template we selected. Here I have selected the Android view, so it filters already to the classes and files that are important to build the Android application. But if you switch to project, then you can see like all the files and structures and so on. Let's go back to Android. All right, let's start with the basic and important thing, that is the build Gradle scripts. So there are, when you create a project, there is always one build Gradle script on the root of the project that defines which dependencies on plugins are you using. And it is important that you have obviously the Android build Gradle tools plugin here. That will help you to build the Android application. And as well, because we selected Kotlin, we are having here the Kotlin Gradle plugin. We're going to be using the latest stable version of Kotlin, that is the 1.3.72. So the build Gradle is this build Gradle scripts will help the Gradle build tool to actually build our application by including the plugins necessary to do so. Then in your model, so a model is normally one of the folders that you have on the project that defines either an application, a library, or other types of components. But in this case, we're just going to have one, that is our app module. And we indicate that by applying the plugin called Android application. We are going to be adding as well the Kotlin Android plugin. And these are some extensions that will help us with the development. I will not focus on this part, but basically here we are defining the SDK version we are going to be compiling with. We are going to define in the application ID and the target versions and minimum SDK versions. The important part here is our dependencies. So these are the dependencies that are going to be included when we are building our application. This helps integrating other tools. And in our case, for example, we are adding the Kotlin standard library, and then we are adding some of the Jetpack libraries that will help us bootstrap our application. Adding some extensions or adding the life cycles that I will explain a bit later. At the same time here, I want to quickly just add one configuration that we will need, that is to switch to using Java 1.8 when we compile and Kotlin 1.8 as a target to use some of the libraries that we will be using. And finally, as well, I'm adding one extra library that is the Fragment from the Jetpack library with extension for Kotlin that will help us bootstrapping some of our tools. As you see, when I modify any of these things, you always will have here like a button saying that you need to sync. So basically now Studio will tell Gradle that it needs to rebuild the dependencies, and then it will tell us when it finished and if it succeeds. And that means that the dependencies are now added. All right, so let's switch to the important part here. We are going to have, in any Android application, as you might know, there is always like one activity at least. Normally, by default, like calling it main activity. You can have multiple activities, but it can only be one activity on top. An activity is a component that listens to the life cycle of an Android application, and that it represents the view, it renders the view. We do that by on create. So when the activity is being created, setting the content view or the layout. And it's quite common that we are using fragments instead of having multiple activities. So this is why this template that we choose automatically adds the fragment. Fragment basically is a component that is lifecycle aware as well. So it knows when it goes creates, when it goes on pause, and all this lifecycle of Android. But it can be attached and detached from an activity. And it doesn't have to be full screen. It could be like a small component, and it will depend on which container you are putting in it. So our main fragment here, as you see right now, we are defining how the view is going to look like. We are flighting the view defined by this layout. And then on activity created here, this is marked as deprecated because on the new version of the fragment from the Jetpack library, this is no longer what is recommended, and we will use something else. But I will go into this in a second. So as you see, it automatically adds our view model class. This view model class is part of the Jetpack library that is called Lifecycle Viewmodels, and it is a component that will help us decouple our logic of our application of our view from the view itself. So it is not lifecycle aware, and it only knows that it creates and then it eventually gets destroyed. And it helps to like put our logic. So I don't know, checking that the email is correct, checking that the password is correct, and starting the logging process from what is the actual view. So I like to think also about a component that takes some input from either the user or from other components, and then it outputs a state that then the view is rendering. I will get into details in a second. And then finally, we have our layout. Oops. Yeah, here. We have our layout for our fragment that is defined here, and it's kind of a drag and drop screen where you can do things, and then you have the layout that you can modify. For example, I can say I can modify here the text, and it will automatically show here. All right, so we have now seen the main component that we want. So let's get into code. I just want to make sure that everyone is on the same page before starting. I will quickly just rename this to login, just to distinguish, because this is our login screen. So now we have our login components. And how I like to start is thinking about the interface that I want to build, but from the business logic perspective. What does that mean is like not how it will look like. So what does this flow needs to do? How, based on some inputs, how the outputs are. And this defines the logic of this screen itself. And I like to start this because then we ensure that the view, it's not dependent on the logic, and the logic will not depend on how you structured your view. One of the common practice that I like to do with the view models is define something that is called a view state. So based on some inputs that the view model will have, it will output the view state. A view state is a component, a class that will tell the view which state is it, and it will pass some parameters to construct this view. So then the view, in our case, our fragment, will take it and then represent it. So a common practice to do that is using something called sealed classes. So we are going to call this logging view state. And a sealed class is, how to explain it correctly? So it's a class that allows you to represent a constraint hierarchy in which an object can only be of the given types. So this is the standard description of it. But what it means is, think it about as an enum from Java, if you might know, with superpowers. Because an enum, you can only define it, and it's kind of a static object, while on a sealed class, you can still use instance of classes. You can do create an instance of this class. But you will see the benefit of this when we go later on in the code. All right, so which are the states that the view can be based on the input from the user or based on some progressing of how the logging is happening? So we have a state idle, right? So when we just started, there is nothing that happened, and the first thing that we have to tell the view is, yeah, just you're an idle state. I'm going to use here like an object class. So this is thinking as a static class. You cannot create a new instance of this. It's only one. And it extends to our seal class. So this defines that this idle object is part of this seal class. Another state that we might be is when the user inputs the email and the password, right? And we submit this into our backend, and we get into the progress state. So we are telling the view, hey, you're on the progress state. Then when this progress finishes, the flow, we can either it can either have failed or it can either have succeed. So in case it failed, then we maybe want to use and show a message to the user. So we are going to use here, instead of an object, a data class. Data class basically will allow us, it's a nice part of Kotlin that tells that this class, the parameters that they are defined on this class, they will automatically get getters and setters, and will be used as equals comparison and for the hash code. So you don't need to have to implement this. In Java here, you would have to make getters and setters and hash codes and equals for all of this. So the same for our other state, that is, it succeeds. Succeed. So in the case that it succeeds, then we will be in this state, and maybe we want to use to show a message to the user. So this is like the 4 states that our view can be. Now, how we are gonna tell this to the view that happened? We could obviously just have a variable here that will define the state, right? And then, for example, we could just start with being idle. So this would keep our state on the view model, and then the view can check this variable and define that. But how the view gets notified that this variable has changed? There are different practices out there. One of the common ones that Android Jetpack offers is the so-called live data. Live data will allow to observe a variable based on the life cycle of the component that is observing. Because remember that we want to keep the view model completely decoupled from the view. So we don't want to know that the view model should not know about which view is attached or which view is observing this. For this, we use the live data. So live data, it can, So this is a mutable live data. Mutable means that whoever has the reference of this field, it can change the content of this live data. And then we defined which type of value does this live data contain. And then as well, we can define what is the initial status of this live data. So now, for example, if I take this live data, I can access the value of it. And I can as well modify the value of it. And then on the view, we are going to show this later, you can observe. Do you see these methods here? It will allow you to observe this live data, and it will notify the observer every time the value changes. You might have wondered, why did I make it private, and why did I make this like underscore here? So this is a kind of a practice or common standard. There are different ways to do it, but I kind of like to indicate that this is kind of a baking field, because what we want to do is that the view can only access to the live data, but is not able to change the value inside. So instead, we are going to expose, so we're going to make public a live data of this view state that is using this field. But as you see, I'm assigning a mutable live data, but I'm saying that this is actually a live data. So if I now try to access the state live data value, I can. But if I try to modify it, it's not allowing me. It is complaining that I cannot assign this value because it's not mutable. It does not have this header. All right, so now using this, we are exposing the view state to the component that might be observing this view model. In our case, the view, so the fragment. Next, I mentioned, so this is our output, right? So this is based on some inputs. We are going to change this state, this view state, that is output for whoever is observing. So what is the inputs that now we can have for this logging string? Well, I would say that the submit button, correct? So we can have a user clicking on submit and passing us the email and password. So based on this input, we are now going to change our output, the state, either by maybe failing because we are validating if the email and the password has the right, they are correct, or switching to a progress state because we are starting the logging process. To do that, let's use a when statement to go for each of these cases. So on the first case, we're going to check if the email is invalid. We are going to help us using here a method. And if in the case that the method is invalid, we want to update our state and go into a failed state that has the message email is invalid, for example. So if we want to build this function, we can just create it here, and we are expecting that this will be a Boolean. Because how when statement works is that for each of the statements that you put, it expects a true or false, and if it's true, then it will execute the code that is after that. So for keeping it simple, I'm just gonna say that we are expecting that the email has at least the @ right? So that any email must at least contain, it should contain only one @. Here is where Kotlin is quite nice, and it has a bunch of extensions. One of them being called single. Single basically will try to find that there is only one condition that satisfied the predicate. In our case, we are going to say that if the condition is not found, it just returns null. So what is the condition? The condition is that it goes through every character and tries to check this condition. And if this condition is equal to the method. So if it finds that there are none or more than one it will return null. So if it return null, it means that the email is invalid. So now we are going to go for the second case, where we're going to check if the password is invalid. We are going to actually just copy the same we did before. And in case that the password is invalid, we're going to go into a failed state. But this time, we're going to just change the text to say that the password is invalid. We again create this password function that returns a Boolean. And this time, it will be as simple as just checking that if the password has less than 4 characters, then we say that it's an invalid password. So these are the preconditions in order to submit the logging into our backend. So we do a pre-check here, where if that is not correct, we are gonna change the state of our view to say it failed. In case it's valid, so the email is not invalid and the password is not invalid, then it means that we can go ahead and submit our submit the email and password into our logging service. Before starting that, we want to probably tell the UI to go into a progress state. So we are going to, again, change the value of the live data and say that now it's on a progress state. On this moment on is where normally your view model will communicate with the logging repository, logging service. There are different ways of doing that. But for the sake of the example, I'm going to keep it super simple. And I'm just going to create a quick method here that will fake the process of the logging. And I'm going to use here a nice technique that they are called Lambda Parameters. That as you see this parameter, it's having this kind of syntax here. This syntax means that this indicates that that will be a lambda, so that these two parentheses are going to be a lambda, that it's going to be passed a boolean into it, and this lambda should return unit, so it's not expecting any value. Why is this nice? Because look now, when I start typing the method name, you see that it's already offering me to use this, and it automatically, it's a nice thing of calling that converts any function that has a lambda as the last parameter. You can already skip like the parentheses and just go with the brackets and get the value here. So in our case, it will be as succeed. And then you define the name of the parameter that is returning. So if it actually succeeds, we want to update the view state to say another message saying, "Yeah, welcome back," for example. In case it did not, we want to go into the failure state where we are going to tell the user login has failed, for example. So what happened here is that after I validate the email, after I validate the password, that means that I go into the progress state, and then I'm submitting the logging. When the login process finishes, this call will be called, and I'm going to check if it succeeds and update the state, or if it failed and update the state. So we are missing here to implement this process logging. Here, I'm going to use a kind of a dirty trick that is to post delay this into the main thread. So I'm taking the handler. This is an interface on Android that allows us to post executions and to delay them. On this case, I'm saying execute in 2000 milliseconds, so 2 seconds, the code in here. And then the code in here, for now, it will be just calling the Lambda parameter with the value of true. So this is basically just kind of taking a delay of 2 seconds and then just saying that it's succeeded. All right, so this we don't need anymore. So let's review. We have our view model that offers an output that can be observed with the state of the view. We have our input, that is the user that can input an email and a password. And based on this, we will change the output. So now let's go back to our logging fragment, where we are going to wire the view model with the view. So fragment, it's a component that is lifecycle aware, and it's useful that it represents like the view that we are defining, that we are creating. But at the same time, it allows us to wire this view, so change render it differently based on, for example, the view model state, so the view state. To do so, I'm going to start by changing here this into a val and using a new technique that it's on one of the Jetpack libraries, that it's called using delegation. So this by means that it's delegating the initialization of this field by these view models. This basically does all the wiring to create the view model and assign it to this variable. And I'm not going to go into the details, but just know that when we are using this view model later on our lifecycle, it's already going to be initialized for us. So this, we don't need it anymore. And now what happened is that we want to, when the view is created, we want to initialize the different view components and wire them to the view model. Before we get into that, we need to define our view, okay? So we need to add our edit tags and so on. But for the sake of this presentation, I'm not going to live code, I'm just going to do a copy paste here of the different components, but I'm going to explain them. So I choose right now copy paste our view layout, and as you see here, this is how it looks. We have a title, we have a input, an edit text to put your email, to put your password, and a submit button. So if I select the component here, you see that it highlights, shows quite bad, but yeah. I think that you should have to play with all the different components and views that you can add here. So I will just go through it. So this is the text view that basically can represent the title, and then there is edit text that it will be our email, and we are defining that the input type of this edit text can only be an email address, and for the password we define that the input type can only be a text password. This automatically will add like the asterisks for us when there is an input. We have a button, and then we are adding a progress view to indicate when the logging is happening. But we started with the visibility set to gone, meaning it will not be visible directly. An important thing for here is the ID. So every view has an ID, and this is how then the Fragment can find these IDs and use the components. So let's go back to our login fragment. So again, now we inflate the layout, as you have seen, with the edit text and the button. And then when this happens on the lifecycle, then the view is finally created, and Android will call us here. This is where we can, for example, take the view and find views by ID. For example, we want to find our button. So we are going to pass the ID of our button, that it was submit button. This method basically will go through all the different views, different childs of this view, and try to find this ID. Once it finds it, it will return us the type of view, in this case a button, that now we can just use it. So for example, we can use the set on click listener. So we are attaching a listener to this button that will be called back when the user clicks on the button. This is a way that it's like the common way on Android to find views and to wire them here on your fragments or activities. But there are other frameworks or mechanisms to do that. One is what we call view binding. And another one is one offered by Kotlin Android extensions, that it automatically adds the all the syntaxes and all this for you. So here now I remove that, and it's telling us that this submit button could be imported. So if I do import it, we can see here that it actually imports all the different fields from our layout. This mechanism has some pros and cons, and I would definitely recommend to use view bindings or simple find by views, but it makes for the sake of this example, really easy now to code, because we can just use the same IDs on our layout to access to the view components. All right, so now let's wire. So by getting the instance of this button and assigning a click listener, we are wiring the view with the fragment. And now we need to wire the view model with this input. If you remember, we had a method created on our view model that accepted an email and a password. So how we get the email is we are going to get the email edit text from our layout. And we are going to get the text that is currently there on the moment that the user clicks on click. And we are going to, we're going to transform it to string and pass it to this. And we are going to just do the same for the password. Oops. All right. So in this moment, when the user clicks the button, then we will submit into the view model the content of our email edit text box and our password. So we now wire the view inputs with the fragment, and then the fragments forwards this to our view model. The last step is wiring the view model output, so the view state with our fragment that then will tell the view how it should update, how it should render. So we get our instance of the view model. We get the field that we expose, that's the state live data. And now we can observe this live data by passing a lifecycle observer. On the case of the fragments, we have the view lifecycle owner that we will pass. This is a lifecycle observer that will help with the so observing when the fragment is there, but removing the observer when the fragment is not there anymore, so we don't have any leaks. And then finally, this requires, oh, I did something wrong. Observer. Okay, sorry. So we need to pass the observer like that for now. Yeah, all right. So this is an interface that's called observer. If we look into it, it is super simple. It basically has a method that will be called with the value defined here when it changes. So when this change, here we will get our view state, and then now we can use. So every time that the state on the view model of this live data changes, we will get called back here. And now is where the sealed class power comes into the game. So when using a when statement on a variable that is a sealed class, it automatically highlights here, and it tells us that we can actually are missing remaining when branches. So if we select add remaining branches, it automatically adds all the different classes that extends the login view state. And it's a way, like to tell that this abstract class, that is the seal data, knows all the chills that can have, and then you can define it all here on the when statement. So now let's just quickly make here some spaces. Okay. So every time that the view model changes the state on this live data, we are going to be called back here. We are going to get an instance of a view state. This when statement, it's going to tell us which type of instance is. Is it an idle instance? It is a progress instance? It is a failed instance? Or it is a succeed instance? And now here is where we want to modify the view, so update the view based on the state. So let's start with the simple state, that is when the user comes in. We don't want to show the progress bar, right? So we can just tell that the progress view from our layout, we are going to modify the attribute, the visibility attribute, telling that it's gone, so it should not be there. At the same time, we want to clear any possible errors that we might have shown before on our input fields. So for example, the email edit text, we don't want it to be showing any error, and neither the password. And finally, we want to enable the input of edit text. So for example, we can say that the input that is enabled, by default, it is, but I will explain why this is needed in a second. And our submit button will be enabled as well. So now when the user comes for the first time, we will make sure there is no progress view, there are no errors being shown, and that the input is enabled. What happens when we start the progress? So when the user actually submit the email and the password, we want to, one, show the progress bar, and two, we want to ensure that the user is not able to input anything. So again, here we are modifying the visibility of the progress bar, and this time saying that it's visible. And we want to disable the input of email and the input of the password by disabling these classes, so the edit text and the button. So in this moment, what happens is that the progress will show, and email, password, and button will be disabled, so the user cannot even click on it. So now from progress, we can either go to failed or succeed. What happens is that when we wanna, when we go into failed, we want to show an error, right? We want, first of all, in case that there was a progress bar being visible there, we're gonna make it gone. And then in the case that there was an error, we are gonna show an error on the edit text of the email. Normally here, you probably should distinguish between, is the error on the email or is it the password? For the sake of this example, I'm just gonna put the input error on the email. So remember that we have this variable, right? That is our view state. And once we are on this when statement, now Kotlin knows that this view state variable is of the type failed. So it automatically gives access to the field on this class. So if I click here, it automatically goes as to the field state. All right, so now we are showing, we are disabling the progress, and we are showing an error. As well, we need to turn on the input so the user can correct the password or the email, right? And now let's implement the last state when actually the login succeeds. It's similar to the failed, but on this case, we don't want to show an error. So we should go into disable any error in case there was something. And we don't want to enable again that the user can input that. So we are going to set here to false all these values. And finally, we want to show a message. Let's use the login text view, the login title text view to show the message. The message, again, is defined by the view state. So it gives access via the message. So if I click here now, it goes into the data class of the succeed view state here. So now we are going to show as a title this text instead. And actually, that's it. So we have wired our view model with our fragment, and then the fragment tells the view based on the state how it should be representing it. We for sure can clear this up, and there are some cases that we need to handle and so on. But this is more or less all the code. So we have our view model defining the logic based on inputs. It tells an output is the state. and then our fragment wiring things up between the view and the logic. All right, so why don't we just go and try it out? Let's see if that is going to work. So let's bring our emulator. Oh, a second. Yeah, here. Let's bring our emulator. And now we are going to run the application. So Android Studio offers here a way to run it. So you can either create emulators by opening the here, the emulator Android Virtual Devices Manager. It allows you to create an emulator, but the process can take a while. So I already have here some of them created. In this case, we are going to use an emulator that emulates a Pixel 3 running Android 10. So when I click Run App, because it's selected here, the Android Studio will tell Gradle to start building. So here, Gradle build running. It will keep it will start building our application and eventually launch it into our emulator connector. And here we have our login screen that has an email and has a password and the submit button. So let's test something out quickly. So we are adding a quick email and password, but we are missing something. We're missing the add. So if I click add, if I click submit, automatically we are changing the view to be on email is invalid. But now if instead I use some proper email and I click submit, we are going into the progress state. And when that finishes, we are changing the title to yay, welcome back. All right, so that was for this live coding.